Okay, diving into this stack of sources you sent over. We've got articles, some research notes, quick hits. It's all about AI, but kind of split into two really distinct areas.
Right. It feels like we're looking at where AI is potentially headed next on one hand, and then on the other, a totally unexpected way it's being used right now.
Exactly. So our mission in this deep dive is to unpack these sources, figure out what's really important in them, and see how they maybe connect, especially looking at like what comes after the big language models everybody knows, and then this fascinating study using AI on ancient religious texts.
Quite the contrast, isn't it? A bit of future gazing and then ancient history.
It really is. So let's jump into the first big concept from the sources about where AI is evolving. This idea that foundation agents are the next step.
Okay.
One source puts it pretty strongly, calling them what ChatGPT wishes it could be.
That's a good hook, I think, because it gets right to the core difference the sources highlight. LLMs, large language models, they're incredible at, understanding and generating language they can talk. But fundamentally, they don't do things in the real world or even complex digital environments. They can't really act.
Okay, yeah, they're like brilliant conversationalists,
Yeah.
but that's it, limited in action.
Pretty much. Foundation agents, according to these sources, are designed for action. They don't just generate text. They can take steps. They can collaborate with other agents. Some sources even talk about them adapting their behavior by modeling user intent or even simulating emotional vibes to change how they interact based on your mood.
Modeling vibes. That's kind of wild. So how does this acting capability actually work? The source mentions a core loop, right?
Yeah, they use the analogy of playing a video game, actually. It's this constant cycle. Perception, then cognition, then action.
Okay.
They perceive their environment, digital or physical. They process that information, think about it, cognition, and then they take an action. That loop is what allows them to operate more autonomously than a standard LLM.
Okay, so it's that constant cycle of sensing, thinking, and doing that's the big leap. That loop.
Exactly. That's the fundamental mechanism enabling them to act. It's not just input-output like a language model.
Got it. So if that's the core loop, how are they built to do that perception, cognition, action thing? The source talks about this brain-inspired modular design. What are the actual pieces inside?
Right. The modularity is key. It's not just one monolithic program. Think of it like different parts of a brain, each with a specific job, sort of. The sources detail key components. You have the environment that's just whatever space the agent is operating in.
Like a specific website or maybe interacting with software tools
Yes.
or, down the road, a robot moving around a factory.
Precisely. Could be anything. Then there's the sensor actor system. This is their interface with that environment, how they take in information, like eyes or ears, metaphorically, and how they perform actions, hands, so to speak.
Okay, sensing and doing the physical or digital actions. Makes sense.
Yep. And then you have the mental state space. This is, where all the internal stuff happens. Their goals live here, their reasoning processes, their current task.
Right.
And interestingly, this is also where that idea of modeling user vibes fits in understanding the user's context or mood to influence the agent's own behavior.
So, like, they're not just processing instructions. They're also trying to understand the human element, trying to get the context.
That's the idea, yeah. Within that mental state space, there are several core modules. You have the cognition systems. These handle both structured logic, like solving a specific problem with rules, and more free-form reasoning, like brainstorming or planning.
So they can, like, do math and also figure out a creative strategy. Both sides.
That's the aim. Then there are the memory systems. This is crucial. They need short-term memory, like the context window an LLM has during a single conversation.
Okay, the immediate stuff.
But critically, they also need long-term memory. The sources give examples like using vector databases or knowledge graphs. This lets them recall information or experiences from much earlier interactions or data sets, not just the immediate conversation thread.
So they can actually build up knowledge and remember things over long periods, like a person does, not just starting fresh each time.
Exactly. That persistent memory is vital for complex, ongoing tasks. And finally, there's world modeling. This module is about building internal simulations.
Simulations?
Yeah, the agent tries to predict what will happen if it takes a certain action in its environment. It's like running little what-if scenarios internally before committing.
Okay, wow. So perception, cognition, action is the loop. And inside they have these specific components, sensing, acting, a mental space with memory, short and long term, reasoning, and this ability to simulate outcomes. That is significantly more complex than just generating text based on a prompt.
It's definitely presented as a major step up in terms of operational capability and autonomy. And this is where the sources talk about why this is such a big deal, the implications.
Yeah, the part about agents evolving or improving without constant human fine-tuning really stood out in the notes. That
Oh.
seemed significant.
It's called self-enhancement. The idea is agents can learn on the fly, optimize their own processes, or even conduct research to improve their knowledge or skills, kind of like how a human would, figure things out.
Okay, so they're not just doing tasks assigned to them. They can actively work to get better at those tasks or even figure out new ways to do things
Yeah.
without us telling them how.
Precisely. They can adapt and grow their capabilities based on their experiences and goals. And then there's multi-agent systems, the concept that these agents can work together in teams.
Right, teamwork.
Yeah. The sources mention different structures for this, like a star topology where one agent leads, a mesh where they all collaborate peer-to-peer, or a tree which is more hierarchical.
So building actual functional teams of AIs.
Yeah.
Dividing up the work.
Yes, dividing tasks, coordinating efforts.
Yeah.
It's about collective intelligence. The overall significance, as presented in these sources, is that this modular, self-improving, collaborative design is seen as the leap towards true AGI, artificial general intelligence.
AGI, yeah.
Yeah. It allows for intelligence that can tackle a wide range of problems, specialize where needed, work as a team, and critically, evolve without a human hand on the tiller for every single change.
It's a lot to process.
Yeah.
The idea of AIs that can get better on their own and work in teams. Okay, let's shift gears a bit from the future concepts to what's happening right now. You included some sources that are basically today in AI and quick hits. It seems like the current landscape is just buzzing with activity across everything.
Oh, yeah. The pace is just incredible. These quick hits are great because they show the sheer breadth of what's going on, from deep tech to consumer products to safety discussions. It's a lot.
Right. Like just pulling out a few random examples from the sources. Perplexity, the search engine, their CEO is quoted saying their new Comet browser is more than a browser, it's a cognitive operating system.
Mm-hmm.
That sounds, pretty ambitious for a search tool.
It really does. It suggests a really deep integration of AI into the fundamental way you interact with your computer and information, going way beyond just answering queries. Like, it's part of how you think with the machine.
And Google announced updates to Gemini 2.5 Pro, specifically highlighting improvements for coding and creativity tasks, so refining those core model skills. Still pushing the LLMs forward, too.
Yeah, making the existing models more powerful in specific high-value areas. Coding and creative stuff are huge applications.
And then you have OpenAI putting out a report on how they're trying to detect and stop harmful uses and backing common sense rules. So the safety side is clearly a major focus, as it has to be.
An absolutely critical piece as these systems become more capable and widely deployed. You can't ignore that.
Definitely not. And then on the business side, wow, Cursor by Anysphere, that AI coding tool, raising $900 million at nearly a $10 billion valuation.
Huge number.
And showing massive revenue jumps. That just tells you how much value the market sees in tools that significantly boost developer productivity.
The commercial impact is undeniable. Specialized tools built on this underlying AI power are finding huge markets. There's real money flowing.
And the sources even mention some really practical, maybe even unexpected ways people are making money, like guides on creating viral videos with Google's text-to-video tool, VO3.
The creative side again.
Or apparently selling high-value AI infrastructure retainer packages for like $5,000 to $10,000 a month.
It just shows the range, doesn't it? From creating viral social media content to building and maintaining complex AI systems for businesses. It's impacting everything, top to bottom.
It really is. And there were some kind of fun, unique ones, too, like that diplomacy game where 7 AIs battle for world domination, just, for research or fun.
Slight chuckle, yeah, or maybe a bit of both.
Or Jammy Chat, which apparently makes a music playlist just from analyzing your facial expression.
Yeah, the sheer creativity and application is striking. It's serious research, critical safety efforts, major commercial plays, and also just building weird, fun stuff. AI is truly permeating everything.
It definitely feels that way reading through these. Okay, so we've looked at the future of AI with these acting agents, and we've seen the bustling landscape today. Now, let's pivot to probably the most surprising source you included, the one about AI and ancient texts. This feels like a completely different kind of deep dive for AI.
It is, and I think that's why it's so fascinating. It shows that AI isn't just about building future tech or business tools. It can actually shine a completely new light on things we thought we understood for literally thousands of years.
So the core finding here was that AI apparently uncovered distinct writing styles in the Hebrew Bible that suggest multiple authors, and they're claiming this with statistical proof.
That's the big headline from that source. Now, the idea that different parts of the Bible might have different authors or sources, well, that isn't new in scholarship. That's been debated for
Okay,
centuries.
yeah, the documentary hypothesis and all of it.
Exactly. But this study is significant because it used AI to provide, they argue, objective statistical evidence for those distinctions. Not just scholarly interpretation, but numbers.
Okay, that's key objective evidence. But how did the AI actually do that? The source mentioned it wasn't like traditional machine learning, not just feeding it text.
Correct. Traditional machine learning often works best with large, clean, standardized data sets. Ancient manuscripts, especially something like the Hebrew Bible, can be fragmented, heavily edited over time, maybe short sections from different sources cobbled together.
Right, messy data.
Very. So the team didn't just use an off-the-shelf AI. They built a bespoke statistical model specifically designed to handle the unique characteristics of short, potentially edited, fragmented texts like these.
Ah, they built a tool tailored exactly to the problem.
Yep.
Smart. So what did this special model look for? What were the fingerprints it was trying to find?
It compared specific linguistic features across different sections of the text. They looked at things like sentence structures, the specific word usage, which words were preferred or used more often, and the frequency of word roots, what scholars call lemmas.
Lemmas, like
What?
the base form of a word.
Yeah, exactly. Like the base form before you add endings for tense or gender, so really granular stuff.
So it wasn't just looking for like famous quotes or character names, but really subtle patterns in sentence construction
Yeah.
and even the simplest words, like how often they used and or the.
Exactly. The deep structure of the language usage. And the AI identified three main scribal traditions that align broadly with existing scholarly theories: the priestly texts, the Deuteronomistic history, and Deuteronomy. But the key finding is the AI found these three traditions had statistically unique patterns in their language, even in the frequency of seemingly simple words like no or king or grammatical particles, very distinct styles.
Oh, that is cool. It's like the AI picked up on subconscious writing tics that humans couldn't easily quantify across such a large text.
Mhm.
But the source also mentioned a fascinating inconsistency, right? Something didn't fit.
Yes, this was a really intriguing detail. The Ark narrative, a specific section in the book of 1 Samuel, didn't fit neatly into any of the three main writing styles the AI identified.
Huh. So an outlier.
Kind of. The source suggests this might point to an unknown or perhaps even earlier source that scholars haven't definitively categorized using traditional methods, maybe a fourth voice or something older embedded in the text.
Wow. So the AI is not just confirming existing ideas, it's potentially finding evidence of totally new, unidentified sources. That's pretty groundbreaking for that field.
That's the implication they draw. The source highlights that AI has the potential to provide new objective tools for biblical scholarship, moving beyond interpretation or tradition alone by finding these statistically significant patterns. It adds a new layer to the analysis.
That's a pretty amazing application of AI, totally different from building self-acting agents or commercial software. It's like a digital archaeologist digging through language.
It really demonstrates the versatility, taking these powerful pattern-finding capabilities and applying them to areas we might not immediately think of. Humanities, history.
So let's kind of bring it all together. We've taken a look at understanding AI agents that are designed not just to talk, but to act and evolve, maybe even collaborate.
The foundation agents idea.
Then we glanced at the bustling, diverse landscape of AI tools and applications happening right now. Business, creative, safety.
Yeah, the quick hits showing just how much is going on.
And finally, we saw this surprising application of AI shedding new, potentially objective light on ancient religious texts by finding subtle linguistic patterns.
These sources really underscore that AI is moving beyond just getting smarter in terms of language generation. It's becoming capable of independent action, collaboration, and its analytical power is being applied in incredibly diverse and often, totally unexpected ways.
So why should you care about all this? Well, because AI is fundamentally changing what's possible across so many different fields, from building incredibly complex systems that can work together and improve themselves,
Which could change how we work, how businesses operate.
to potentially rewriting our understanding of history, culture, or even ancient texts based on subtle patterns that only machines can easily spot in vast amounts of data. It touches almost everything.
It's about seeing these tools not just as glorified chatbots, but as powerful engines for analysis and capable agents that can interact with the world and help us discover things we simply couldn't uncover on our own. New capabilities, new insights.
And that leaves us with a thought to ponder, pulling from all this. If AI can uncover hidden authorship and inconsistencies in ancient texts by analyzing subtle patterns that humans might miss, what other long-held assumptions, maybe in science, in history, in understanding human language, or even psychology, might AI challenge next by finding patterns we haven't even thought to look for yet? What other hidden structures are out there?
A lot to chew on there. Where else can this pattern-finding power be applied?
Definitely. Thanks for sending over these sources that sparked this deep dive. It was a really insightful, good mix.